This is a video tutorial for Unit 2, pages 2 and 3 in the homework. This was day 2 of Unit 2 is what we covered. Alright, so on day 1, on our other video, on page 1 of the homework, we learned how to do electron configuration, and that's the arrangement of electrons in an atom. Orbital notation is the exact same process, but instead of writing 1s2 like this, like we did last time, we do 1s with 2 lines shown just like this. Now something to remember from the notes was that we have, and I'm just going to write it down here so that y'all can see it, we have our main energy levels, 1, 2, 3, 4, 5, 6, 7, and then we have our 4 sublevels, S, P, D, and F. And when we do these, we're going to count by odd numbers, so S, P, D, F, 1, 3, 5, 7. And that's from day 1 in our notes, that there is 1 s orbital per sublevel, and there are 3 p orbitals per sublevel. And there are 5 d orbitals per sublevel and 7 f orbitals. Now we illustrate or we notate those orbitals with these lines down here. I'm going to call them dashes. When I draw that dash, that is 1 s orbital. Whenever I use the letter S for an s orbital, I always put 1 dash. And so I like to say that S's are studio apartments. An S apartment only has 1 bedroom. P homes, okay? There are 3 p orbitals for energy levels. Whenever you use the letter P, you're going to write 3 orbitals like that. These get 1, 2, 3, 4, 5, and F's get 1, 2, 3, 4, 5, 6, 7. Alright, I just barely fit that on there. So anytime if you want to look up here at our example, vanadium, 1s, after an S I put 1 bedroom, 2s, 2p, that's why there's 1, 2, 3 lines, 3s, 3p, 4s, 3d, 1, 2, 3, 4, 5. Okay. Now if we count up all of these arrows, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. There are 23 arrows, and that means there are 23 electrons. And if you come over here to look at the periodic table, vanadium is number 23. So that's just right, just how we'd expect it to be. So that's our example of vanadium. Now we did these ones in class, so I'm going to skip these ones, even though I gave you the outline. And we're going to come down here and let's do a hard one. So let's look at AS. Alright, and first we need to find AS in the periodic table. It's arsenic. It's right here. This is the wrong side of the periodic table, but it has the name arsenic on it. If we turn over to the electron configuration side, arsenic is still, oh my goodness, right here, number 33. Alright, so what I'm going to do is I'm going to label arsenic as being home by putting a little star on it. Now, I very strongly recommended that students just rip up little pieces of paper like this to do the same thing, but I'm going to use a star and a car. And we are going to give directions from my house, home, your home, 1s1 hydrogen, to arsenic. This is just like we did with orbital notation, okay? The difference, and this is going to have a hard time fitting this on the screen. Haha, I got it. Okay. The difference in this is going to be, instead of writing 1s2, 2s2, I'm going to show the arrows, okay? So in order to get to arsenic, I have to come through this block. And when I get to the end of the block, I write 1s2. So 1s, and then after s, I put a line like that to show that s bedrooms, right, just like this. There's 1 s orbital per energy level. And then I would do 2 arrows, an up arrow and a down arrow, because that is my 2 electrons. Now I do half arrows. My students already know that, but I do half arrows because that's how I was taught, and it's faster. But they have to be 1 up, 1 down, and we always ask you to do the up first, okay? So I had some students ask if they could say 1s2 like this to keep track of it and put the little 2 anyways. I told them they can put the little 2 anyways, but on our example up here, really you shouldn't be putting the S2P6, because that's what 1, 2, 3, 4, 5, 6 arrows mean. But if you want to put those so that you keep track, so it feels more like what we did last class, you can do that. That's fine. I wouldn't cut it off for my students. Okay, so after I get here and I write down that P block, remember, that's the end of the period. There's nothing left to go over here. So after I finish that period, I come down to the next period. And I'm going to go 2s, 2, just like this. And so I'm going to write 2s, 2 if you want, and then put one line, because S houses always get one bedroom. Alright, all that means is there's one s orbital per energy level. And I'm going to put 1, 2 electrons in there, up and then down. And after 2s, I have to come all the way across this period before I can go down. So I come here to 2p. Now p's always get 3 dashes after them, because there are 3 p orbitals per energy level, or 3 bedrooms in a p house. And so for 2p6, I need to put in 6 valence electrons. It matters that you do it in the right order. So 1, 2, 3. These first 3 up arrows are going to get their own bedroom. You have to put them alone first. Alright, let me fix this computer's being goofy. Here we go. You have to put them alone first. And then you can go back and do 4, 5, 6 as down arrows. So there's 2p6. So once I'm done with my 2p6, we come down to 3s2, 3s2, up, down, and then over to 3p6. Remember, whenever I write a p, I put 3 lines up, 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 down, down, down. So 1, 2, 3, 4, 5, 6, 3p6. After that, then I can put my star back on, now that I'm not blocking it. Okay. After that, I come back to this one, and I would write 4s2, 4s, up, down, 2, and then I would come all the way across the end of this block and write 3d10. So 3d and d bedrooms get 5, or excuse me, d houses get 5 bedrooms. So S, P, D, F, 1, 3, 5, 7. Right? Whenever I write the letter D, I write all 5 bedrooms. Okay? 1, 2, 3, 4, 5 orbitals, 10 electrons, so I get them all up first. Okay? Up, 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 and then down, 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 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3d10. And then I would come over here to arsenic. 4p3, right there. So I'm going to write 4p, and anytime I write the letter p, I put 3 bedrooms. Now, where those electrons are matter. It's the Hund principle that says that if there's 3 people, 3 bedrooms, 3 orbitals, and 3 electrons, everyone gets 1 slice of pizza. Okay? I would not do this, and I'm going to put it here as the bad example above it. I would not do 4p, 1, 2, 3, up, down, up. Okay? That would never happen. You would never have an empty bedroom with 2 kids sharing. They'd throw a temper tantrum. Or you'd never have one person that gets no pizza when this guy gets 2. Okay? Friends are going to get in a fight if you hog your pizza. Okay. So there we go. That's what this one would look like. I know that's really time consuming, but look at 33 electrons we should have drawn. And if you count up those arrows, there's 33 of them. Make sure you're drawing these lines down here. They're not optional, those lines on the bottom. Okay? Just like we've been doing. Sorry, I am so congested. This one now says complete the off-bar diagram. We did this one in class, so I'm going to look at this one. The off-bar diagram for phosphorus. I didn't do the off-bar diagram. Okay, it's the same thing. This is orbital notation written out linearly or in a line. It's the off-bar diagram when it's low to high this way. So this means low energy to high energy. So electrons go lazy first, and then they get to high energy. Electrons are going to go lazy first to high energy. So it's the same process. All right. I'm going to try to get this to fit in. I do not know why it doesn't want to work. All right, kind of, sort of. Phosphorus is right here at number 15. Okay, so my electrons are going to go 1s first, up, down, and then 2s, up, down, and then I'm going to come over to 2p, up, 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 down, down, down. After 2p, after number 10, then I come over to number 11, and I'd go up, down, and then phosphorus is 3p3, so we'd go up, up, up. Okay. Now phosphorus should have 15 electrons, and we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 arrows, 15 electrons. That's where they are. All right, so that's how we're doing page 2. If you want to turn over to page 3. Page 3 is fantastic because this is what your test looks like. Let me just tell you right now, this is my bad. I made this page. My mistake. These are the exact same problems. I copied and pasted because it's hard to type this, and I was going to change it, but apparently I didn't. So these are duplicates. Let's look at them. One thing that I had people really struggling with in class is that you need both sides of the periodic table for this. Okay? So when we're identifying configurations, the one that's going to help us is the last one, 3D9. So I need this side of the periodic table to go 3D and then D9 to say that it's copper, Cu. But now I need the other side of the periodic table, Cu, to tell me that copper is in group 11, period 4. Okay, and last year on tests, half of students flipped them and said group 4, period 11. So remember, we write sentences, Mrs. Holmes sounds like she is really congested and this is weird, period. Okay? So this direction is where we write our period. So our period number is this. My group number would be 11. So we need both sides. So when we look at number 14, 2p6, I need this side of the periodic table to find that 2p6 is neon, and I need this side of the periodic table to say that neon is in family 18, or group 18, and in period 2. Also, fun fact, the highest the number here is my period number. So you see how 2, 1, 2, 2, 1, 2, 2, 3, 3, 4, 3, 4. The biggest, the highest principal number is the period number. Otherwise, just find it this way. But there's a fun fact for you. Alright, noble gas notation for titanium. This is what we did last time. So titanium is right here on the periodic table, Ti number 22. And the last noble gas, right, the last noble gas that I passed through on this way, wouldn't be 36. I haven't gotten there yet, but argon, number 18. I've already gone through it. So I would not pick krypton. I haven't gotten to krypton yet. Alright, and titanium is in 3D2, so both of these are right, that titanium's in 3D2, but I didn't skip from krypton to this. I had to go, from argon to this, so 3D2, I'm making a mistake here. Those are both 3D2. I didn't go from argon to here. I went from argon to here, 4s2, and then to 3D2. So C would be my correct answer. You'll see lots of these on your quiz in a couple days. So make sure you're getting ready for identifying noble gas notations. All of them look close because they all end in 3D2. But only these two start with argon, and only this one remembered to drive through 4s2. Oh my heavens, let's look at 20. That's a lot, right? Look at all that craziness right there. And the little 2's are tiny fonts. And this freaks people out. Aufbau's principle. I don't know Aufbau's principle, Mrs. Holmes. You don't need to. Not to answer this question. It says, which of the following breaks Aufbau's principle? So it just means which of the following is not correct. The best thing to do on any test is to find out how it's different, y'all. Okay? So here, they are all 1s2, 2s2. They are all 2s2, 2s2. These are all 2p6. These are all 3s2. And then these ones are all different. So, which one of these is not like the other? Right there. And that breaks Aufbau's principle. It's not correct to go from 2p5. It could end at 2p5, but if you're adding more numbers, then all of these have to be full first. And Aufbau's principle says you fill up low to high. So this one's different from the others because I would have to put 6 electrons in here before I went there. So do it that same way for 19. Noble gas configuration or noble gas notation, that's from day 1. Noble gas notation, be working on that. Which one's the correct for argon? And so a lot of people, please be careful. Don't let us trick you on this. Don't let us trick you on this. A lot of people go to argon and say, argon's at 3p6. That's 3p1. That one's wrong. That one's 3p5. That one's wrong. That one's 3p6. Maybe. That one's 4p6. No. Okay? So there we go. There would be our right answer, 3p6. But what if this one wasn't 3p6? What if this one said didn't say 4p6, it said 3p6. What if they both ended in 3p6? Okay, so you need to check the other ones. 1s2, 2s2, 2p6, 3s2, 3p6. So you look at the last one first for identifying configurations, but also check the rest that the rest is correct. Alright. Number 27, explain what's wrong, and let me give you a hint. This guy ate 2 pieces of pizza, and these guys are hungry. Alright, good job with this, y'all. Come in for video tutorials, especially if you've been absent. We can teach you this after school in tutorials in like 5 minutes, one-on-one. Okay, so make sure you're coming in and getting help. Good luck!